everyone! Learning target 6, unit circle trig. My heart, Mrs. Oshier.
And Miss LaHart.
And here we go.
All right.
Oh,
yes.
Those are pretty.
Some of these you haven't seen. Last year in Algebra 2, you were introduced to the sine wave. You were introduced to the cosine wave. And then we have tangent, cosecant, secant, cotangent. We might have showed them to you, but highly doubt that you remember. But anyway, this chapter, you're going to have to be able to graph all 6 of these.
All 6, people. Let's do this thing.
So we're going to start first with the basics, kind of like the vocabulary of this chapter, because when we say things, you have to know what we're meaning. When we talk about the amplitude, it's half the distance between the max and the min of the values. This only works really for sine and cosine.
Okay, yes, because the amplitude, right, it's the height, essentially. Amplitude is how high up and down it goes. So it's that distance from the midline. So in all the examples we're showing you, the midline is the x-axis. So it's that distance up and down from that midline. Okay. You can always find the amplitude by simply subtracting your highest and lowest values and dividing by 2.
Yep. A lot of times you can look, we'll get into how to find the amplitude of the thing, but you can see the amplitude of the first graph is 1, the amplitude of the, 3, and it just goes up. You can see the physical concept of it, I guess.
If we shift this up, that's why this guy comes in handy, because sometimes you can't tell where the midline is, so you just quickly do max minus min divided by 2, and bam, you got it.
All right, so that's amplitude. Now we got frequency. Frequency is the number of curves in 2 pi. When you graph, you're going to graph in radians, so you have to get used to knowing certain values. 2 pi is 360 degrees. Right. So in a circle, the frequency represents how many curves of the sine and cosine graph you're going to see in 360 degrees.
And now the period is the length of the interval needed to complete one cycle. So you have frequency, so how many cycles happen by 2 pi. The period is how long it takes for just one of those cycles to finish. So here I'm looking at a sine wave. So I would see that my first sine wave ends here. So my period would be 1, because I have 1 by 2 pi. Now if I went, right, if I had a whole lot of like 3, that would be, 2 pi divided by 3, because I would have had 3 happen by then. You can always find the period by doing 2 pi divided by the b value. That's a coefficient in the formula.
Yep, we'll get into that right now.
Hey, right there, look at that.
Okay, so when we talk about A, it's just the it's just the letter A. It does represent amplitude, which is a connection, AA, but it is just the value of your amplitude. So you get it from the beginning of your sine and cosine graph.
So A is the coefficient in front of the function. B is the coefficient in front of the variable.
If you click, I think the words pop up.
Oh, boom, look at us go.
So A is amplitude, the B value you get with the X, and that's the frequency.
Okay, so from here, amplitude, frequency, period is what you're always going to be looking for. So we can quickly say, okay, my amplitude is 5.
Because it's right in front of the cosine value.
My frequency is 1/3. That's the easy part. Now, getting the period is also easy. You just do 2 pi divided by your frequency. So 2 pi over B. And when you divide fractions, you multiply by the reciprocal, so you get 6 pi.
Now, if you're nervous with doing the math like that, just remember, do 2 divided by, open up a parenthesis, put 1/3 in, or use your, calculator. It'll give you 6, and then you just stick the pi with it.
Right. Treat pi like an x if you're going to use this in the calculator, and then pop it back on.
Okay. Amplitude. Now, it's not negative 1/4. It's always going to be a positive distance, so your amplitude in this case is 1/4.
Our frequency is 2. 2 pi divided by 2 is pi.
Very simple.
So again, let's talk about what this means. It means it's going to go up and down 5 units. I'm going to have 1/3 of a cycle by 2 pi, and 1 cycle completes by 6 pi.
Ooh, good one. So this one, your amplitude, your distance would be 1/4. Okay. You would see 2 cycles in 2 pi, and then to see 1 cycle, you would just need to go out pi, which is 180 degrees.
Boom.
Okay, now secant and cosecant and tangent and cotangent, they have a little bit of an issue with amplitude. There is no amplitude. So you're just going to write none for amplitude.
They go to infinity, so they don't ever stop. So these are more like critical points. They're like max and mins of specific curves. So that it is important to know that 10 value, but if we ask you what's the amplitude, it doesn't have one.
So you'll say none. It's still the same concept with frequency and period. Way to switch up the numbers, Miss LaHart. 1/3, 2 pi 6. Same thing with number 4. You have none. Frequency is 3. 2 pi divided by 3. That's easy. It's just 2 pi divided by 3.
I like it when it's easy.
Okay, so tangent is a little different for period. A little bit different.
A little bit different.
Okay, again, amplitude is still the same. None. frequency 6. Instead of doing 2 pi divided by 6, you're going to do just pi divided by 6.
A little bit tricky. Okay, we will explain this a little bit more in class so you guys can understand why we're going from 2 pi to pi, but it's because tangent is actually undefined at certain points, so that changes how the period works.
Okay, same thing for cotangent. We have none, 1/2, and then again, you do pi divided by 1/2. Oh, there it is, pi
There
over
it
b. I knew it was going to pop up eventually.
Boom.
Okay, so again, what does that mean? So for number 5, we are going to see in 2 pi, 6 graphs of tangent, and then how long for 1? Pi over 6.
Okay, so for the cotangent, we would see 1/2 of a cycle by 2 pi, or excuse me, by pi, because our frequency changes, and then a full cycle ends by 2 pi.
Yep.
So that is it. We will see you all in class. Have a fantastic day.